Hi sir, this is T Kushi from ITA and my roll number is 37 and my topic for Tech Talk for CD subjected is Beyond Blocks, Syntax and Semantics. So, beyond blocks, syntax and semantics, the terms syntax and semantics are fundamental concepts in the field of programming languages and linguistics. Let's explore each of these concepts and discuss their importance in programming language. So, generally, syntax and semantics are the basic concepts which we discuss in every programming languages. Because as you all know, our compiler has 6 phases. In that 6 phases, syntax and semantics are one of the most important phases. First, we'll have lexical phase, then followed by syntax analysis, semantic analysis, intermediate code generator, code optimizer, and code generator. So, in that, you can know that syntax and semantics are one of the stages of the compiler. So, they play a crucial role in each and every programming language. So, semantics, the interpretation of the meaning of a word or a phrase is called as semantics. And coming to syntax, the arrangement of words in a sentence is called as syntax. So, here you can see in the picture the example of syntax and semantics. So, semantics means you are interpreting a message. So, if a line is given, you're trying to extract the meaning from that line or that from that word. So, that is called as semantics. And coming to syntax, the arrangement of any sentence or words in a sentence is called as syntax. For example, the man walks the dog. Is that syntax is wrong? The dog walks with the man. So that is a correct sentence. So this is the basic definition for semantics and syntax. So coming to the proper definition, coming to the syntax definition, syntax refers to the set of rules that dictate how programs written in a particular language are structured. It defines the combinations of symbols, keywords, and other elements that are considered valid and meaningful in the language. Coming to its importance, proper syntax is crucial because it ensures that the code is well formed and can be understood by the compiler or interpreter. Syntax errors occur when the code violates the rules of the programming language, making it challenging for the computer to interpret and execute. So, coming to the syntax, syntax refers to the symbols or keywords or other elements which are being used in a programming language, so which should be valid and meaningful. That is nothing but a syntax. So for every programming language, you'll have a particular syntax. For example, for Python, you'll have a particular syntax. For C, you'll have a particular syntax. So each and every language has its own syntax, like in which format we have to write, which is a valid way of writing, so that the computer can understand it in an easier manner. So the importance of syntax is that it is crucial to maintain syntax in each and every language. If the syntax is not maintained, the proper meaning cannot be extracted and the computer cannot execute the program and give the proper appropriate answer. So proper syntax is crucial because it ensures that the code is well formed and can be understood by the compiler or interpreter. Syntax errors occur when the code violates the rules of the programming language, making it challenging for the computer to interpret and execute. So, this is the reason syntax is important for each and every proper language to provide a valid and a meaningful sentences in that particular language. Coming to semantics, semantics, on the other hand, deals with the meaning of the code. It defines the relationship between the syntactical correct elements of a program and their intended behavior. Coming to this importance, while correct syntax is necessary, it does not guarantee that a program will behave as expected. Semantics ensure that the program executes in a way that aligns with the programmer's intent. Errors in semantics can lead to logical errors where the program runs without syntax errors but produces incorrect results. So, the first main part of a programming language is having proper syntaxes. Coming to the second part, it is semantics. So, even if the code is free of syntax errors, but there are chances that due to semantic errors, you will not get the expected output. So to get the expected output as a user need, semantic error should also be managed. So semantic error generally is used to know the meaning of the code, like what is the actual meaning of the code, what result should be produced according to the need of the user. So it defines the relationship between the syntactically correct elements of a program and their intended behavior. So, why semantics is important? Because while correct syntax is necessary, it doesn't guarantee that a program will behave as expected. Semantics ensure that the program executes in a way that the user wants, so that whatever user want, in that way, the program can be executed with the help of semantics. So that is some major thing, because if the syntax errors are not there, but still you will not still the user will not receive the proper output as expected, then it is also an error. So in such cases, semantics plays a crucial role. Errors in semantics can lead to logical errors where programs run without syntax errors but produces incorrect results. Beyond blocks and syntax, modern programming languages often extend beyond traditional block structures to incorporate more flexible constructs. For example, languages like Python and Ruby use indentation to define code blocks instead of explicit braces or keywords. Some languages introduce syntactic sugar, which provides more readable or expressive ways to write code without changing its underlying meaning. This can include features like list compressions, lambda expressions, and more. So, coming to beyond block in syntax, so modern programming languages often had brought many changes based on traditional languages. For example, in traditional languages like C, Java, or C++, you'll have a block-like structure where everything is written between the brackets, like curly braces, like that. But coming to the languages like Python, Ruby, we use indentations instead of those explicit brackets. So this is called as beyond the blocks. So here you will not have a block-like structure. Instead of that block-like structure, we are using indentations. So that is a major difference. And some languages also introduce syntactic sugar, which provides more readable or expressive way to write the code without changing it. This can include features like list compressions, lambda expressions, and more. Next, coming to the beyond blocks in semantics, advanced programming language incorporates sophisticated semantics to enhance experiments and enable more powerful abstractions. Features like closures, first class functions, and metaprogramming allow developers to write more flexible and reusable codes. Domain specific languages often have semantic tailored to a specific domain, making it easier to express complex concepts in a concise and a natural way. Concurrent programming models and languages provide semantics for dealing with parallel execution, ensuring that programs can effectively utilize multiple cores or processes. So, coming to beyond blocks in semantics, it is an advanced programming language in which the program's abstractions are more powerful. Features like closures, first class functions, metaprogramming allows developer to write the code in a more flexible manner, and they allow the codes to be reused again and again. And the domain specific languages, that are DCLs, often have semantic tailored specific problem domains. So it is a more concise and natural way to express complex concepts. And it also helps, beyond blocks and semantics also helps in providing parallel execution. So parallelly, you can perform more than one task, so ensuring that programs can effectively utilize multiple cores or processes. Next, beyond blocks, functions and procedures. So first, coming to syntax. Syntax describes how functions or procedures are declared and invoked, specifying the orders and types of parameters. So how functions are defined, how are they invoked, how are they called. These are all given in functions and procedures of syntax. That is, you'll have call by value, call by reference, and in what order they are present, and what type of parameters you are using. All that comes under syntax. And coming to semantics, it defines the purpose of the function or procedure and the effect it has when it is executed. So it has object-oriented concepts such as syntax encompasses class and object declarations, method calls, inheritance, etc. Coming to semantics, it takes care about the behavior of the objects, how inheritance is implemented, and how methods interact with object instances. Next is concurrency and parallelism. So coming to the syntax, it involves constructs for creating threads, process, or other concurrent entities. Coming to semantics, it deals with the execution of order, communication between concurrent entities, and potential conflicts. So concurrence or parallelism is nothing but by using beyond block syntax and semantics, the user can execute parallel execution is possible. That is, at one go, user can perform multiple tasks. So when coming to syntax, it helps in involving the construction of threads, processes, or other concurrent entities. And coming to semantics, it deals with the execution of order, communication between concurrent entities, and potential conflicts. Coming to domain-specific languages, here, coming to syntax, in domain-specific languages, syntaxes are tailored to a specific problem domain, often with a specialized vocabulary. So syntax is tailored means it is dedicated to a specific problem domain with a specialized vocabulary. For that, you will have a specialized vocabulary. Coming to semantics, it reflects the meaning of the constraints in the context of the targeted domain. In syntax, how in a specialized way, how it should be written so that the problem can be solved. And coming to syntax, it helps in knowing the meaning or constructing the meaning of the context in which that targeted domain is present. So coming to web development, in coming to syntax, HTML defines the structure, CSS presentation, and JavaScript the behavior. And coming to semantics, it determines how the web pages look, behave, and interact with the user. Coming to natural language processing, in syntax, it involves the grammatical rules governing sentence structure. And coming to semantics, it is concerned with understanding the meaning of words, phrases, and sentences. Coming to machine learning models, in machine learning models, it describes the architecture, layers, and parameters of a model. It's coming to semantics, it specifies how the model learns patterns, makes predictions, and generalizes the new data. Understanding both syntax and semantics is crucial for effective communication and problem solving in various domains, not just limited to traditional programming constraints. So whether you're designing a programming language or creating a DCL or working with complex systems, considering both syntax and semantics is essential for clarity and correctness. In summary, while syntax and semantics form the foundation of the programming languages, advancements in the language often go beyond traditional block structures. Modern languages aim to provide more expressive syntax and powerful semantics to make the code more readable, maintainable, and efficient. So let us know the difference between syntax analysis and semantic analysis. So coming to syntax analysis, in syntax analysis, process of analyzing a string of symbols either in natural language, computer languages, or data structures conforming to the rules of a formal grammar, that is syntax analysis. Coming to semantic analysis, process of checking whether the generated parse tree is according to the rules of the programming language or not. And it parser performs syntax analysis. Semantic analyzer performs semantic analysis. Second phase of the compilation process is syntax, and the third phase of the compilation process is semantic analysis. It takes the tokens as input and generates a parse tree as output. Checks whether the parse tree is according to the rules of the language or not. Here it generates a parse tree. Here generates an annotated syntax tree. So the major difference is that here in syntax analysis, it is the second phase of the compiler. Semantic is third phase of the compiler. And syntax analysis, it builds the parse tree of the given grammar. Semantic analysis is used to check whether the produced or generated parse tree is correct according to the rules of programming language or not. And here it takes tokens as syntax analysis, it takes tokens as input. Here it checks whether the parse tree is according to the rules of the language or not. It generates a parse tree. Syntax analysis basically generates a parse tree, whereas semantic analysis, it generates an annotated syntax tree. So I hope you guys understood that why is it important to know about syntax and semantic analysis, because it plays a crucial role in every programming language. Every programming language will have a proper syntax and semantics. Either it is a traditional programming language or a modern programming language, because syntax and semantics of any programming language helps in maintaining the code in a proper way, in a stable, maintainable, and reusable way. So syntax and semantic analysis plays a crucial role in programming language, and it is very important. And the basic idea is that syntax analysis means it tells how, in what way code should be written or a code should be generated. And semantic analysis, it checks whether the generated code is correct or not. So that is the basic thing, that syntax analysis and semantic analysis. I hope you got a basic idea or a brief idea about it. Thank you so much.